Science and Technology, Part 1st, Standard 9th, Chapter number 3, Current Electricity. Dear student, in this chapter we are going to discuss what is meant by current. What are the uses of current? Where it is used? If power supply fails, what will happen? Which are the domestic appliances works on electric current? All such questions will be answered in this chapter. Student, make the list of domestic appliances like fridge, oven, fan, mixer, washing machine, vacuum cleaner, roti maker, dryer, trimmer, TV, radio, all works on current. Then what is this current means? Students, current is a flow of electron. Let me repeat. Current is a flow of electron. That is, electron from any conductor produces the current. Now, what is this conductor? What is the definition of conductor? Substances that allows the current to flow. Substances that allows the current, that is electron, to flow. For example, such substances are copper, iron, silver, gold, etc. That means all the metals. Now, what is meant by insulator then? What is the definition of insulator? Substances that does not allow to flow the current or electron, and those substances are rubber, plastic, wood, etc. Students, current is denoted by letter I, and the current is measured in the unit called as ampere, denoted by capital letter A. Therefore, current, which is equal to I, and that is equal to Q by T, where Q is nothing but flow of charge and T means time. So, current is nothing but the charge passing through a conductor in unit time. Its SI unit is coulomb. The charge on one electron is 1.6 into 10 raised to minus 19 coulomb. The charge on one electron is 1.6 into 10 raised to minus 19 coulomb. Now let us discuss about 1 ampere current. What is meant by 1 ampere current? So 1 ampere current equal to 1 coulomb upon 1 second. 1 coulomb upon 1 second. That is, current is said to be 1 ampere when 1 coulomb of charge passes through a conductor in 1 second. So let me repeat this. How will you define 1 ampere current? A current is said to be 1 ampere when 1 coulomb charge passes through a conductor in 1 second. Very small values of current are expressed as 1 milliampere, which is equal to 10 raised to minus 3 ampere. These are the small units. 1 ampere, 1 milliampere, 1 microampere. These are all small units. So 1 milli ampere, which is equal to 10 raised to minus 3 ampere, and 1 microampere, which is equal to 10 raised to minus 6 ampere. French scientist Ampere done number of experiments, so the unit of current is ampere. Always remember this. This is all about electric current. Now next point is potential difference. Before going to discuss potential difference, we should know what is electric potential. To understand this, do one simple experiment, or remember one simple experiment. You know that water flows from higher level to lower one. Water flows from higher level to lower one. Just like that, electric charge between 2 points depends upon kind of electric level. This level is called as electric potential. That is, charge flows from higher level to lower level. That is, higher potential to lower potential. And the difference between higher potential to lower potential is called potential difference. Students, work is done to carry out unit positive charge from one point at a higher level to the another point which is at a lower level. Work is done to carry unit positive charge from point at higher level to the point at lower level, and this is called electric potential between 2 points. That is potential difference between 2 points, which is equal to work done divided by total charge transferred from one point to another. This potential difference is denoted by letter V, which is equal to W by Q. So take the units of W and Q. You will come to know that 1 volt, which is equal to 1 joule upon 1 coulomb. Why 1 joule? Because the unit of work is joule, and where the unit of charge is coulomb. Therefore, 1 volt equal to 1 joule upon 1 coulomb. Now, what is 1 volt potential difference then? What is 1 volt? So, the potential difference is said to be 1 volt when 1 joule of work is done in sending 1 coulomb of charge from point A to B, that is from one point to another point. So let me repeat the definition of 1 volt. The potential difference is said to be 1 volt when 1 joule of work is done in sending 1 coulomb of charge from point A to B, or from one point to another. The unit of potential difference is volt, and it is denoted by letter V in the honor of Italian scientist Volta. Very small values of potential difference are expressed as, like ampere. This voltage or potential difference can be also be expressed in very small units. So 1 millivolt equal to 10 raised to minus 3 volt. 1 microvolt equal to 10 raised to minus 6 volt. And large values of potential difference are expressed as 1 kilovolt, which is equal to 10 raised to 3 volt, and 1 megavolt equal to 10 raised to 6 volt. Student, knowing this current and potential difference, Now come to the point that how current flows through a wire. Wire means conducting wire. How the current flows through that wire. To understand this concept, first we should know about the free electron. Now what is meant by free electron? Free electron means the electron which are present in the outermost shell of an atom. Free electron means the electrons which are located in the last orbit or outermost orbit of the atom. So these are called as a free electron. And these free electrons are very weakly bounded with the nucleus. These are bounded with nucleus but very weakly bounded. These free electrons carry the electricity, that means they carry the electric current. Therefore, free electrons are at the state of random motion, but when potential difference is applied, then they arrange themselves in a continuous manner. So before applying any potential difference, the free electrons are in the state of random motion in a particular or in a given conductor. But when the potential difference is applied to that conducting wire, then they arrange themselves in a continuous manner and they flows in a continuously. Due to this motion, they collide with each other. When they are flowing through the conductor, when they are in motion through that conductor, then they collide with each other. So their kinetic energy increases due to their collision. Their kinetic energy increases, and as their kinetic energy increases, the thermal energy also increases. Let me repeat. When these free electrons are in motion, they collide with each other. Due to their collision, their kinetic energy increases. Due to increased kinetic energy, the thermal energy of those electrons increases, and as thermal energy increases, the wire gets heated. So, how the current flows actually throughout that wire or a conductor, you will come to know that because of the free electron. So, definition of current, it's a motion of electron. So, due to the motion of electron, the current flows in a conducting wire. Now, let us discuss about Ohm's law, that is a new point. German physicist Georg Simon Ohm, given the relationship between current flowing through the conductor and the potential difference, that is V, produced. What he had given the relation? German scientist Georg Ohm had given the relationship between current flowing through the conductor and potential difference produced across the end of the conductor. So according to him, what is the statement? According to him, the current flowing through the conductor is directly proportional to the potential difference produced across the ends of the conductor. But condition is that the physical state of conductor remains same. Let me repeat. According to Ohm, the current flowing in a conductor is directly proportional to the potential difference produced across the ends of the conductor, as long as the physical state of the conductor remains same. That is, current I is directly proportional to V. current I is directly proportional to V. Therefore, current I equal to K into V, where K is proportionality constant. Now, just rearrange the term and you will get the equation that V equal to IR. V equal to IR, where R is the resistance of the conductor. So what is Ohm's law? V equal to IR, or V by I equal to R, that is the resistance of that conductor. So this is all about Ohm's law. The unit of resistance is Ohm. The unit of resistance is Ohm, and 1 Ohm equal to 1 volt upon 1 ampere. 1 Ohm equal to 1 volt upon 1 ampere. Now what is the definition? How will you define 1 Ohm resistance? I will define 1 Ohm resistance. The resistance is said to be 1 Ohm. Very simple. The resistance is said to be 1 Ohm when 1 ampere current flows through the conductor, produces 1 volt potential difference. The resistance is said to be 1 Ohm when 1 ampere current produces the potential difference of 1 volt. Now, what is meant by resistivity? What is meant by resistivity? At a given temperature, the resistance, that is R, of a conductor depends upon the length of the conductor L and the area of cross section, that is A, and the material it is made up of. So according to Ohm's law, or according to Ohm, resistance R of that conductor is directly proportional to length of that conductor, that is L. So R is directly proportional to L. Also, R is inversely proportional to area, that is R inversely proportional means 1 upon A. So what will be the equation? That is R equal to rho into L by A, where rho is nothing but the resistivity of that conductor, and the unit of resistivity is Ohm meter. The unit of resistance is different and the unit of resistivity is different. The unit of resistance is simply Ohm, whereas the unit of resistivity is Ohm into meter. Now, what is meant by electric circuit? What is meant by electric circuit? It's a continuous path of an electric current through a conducting wire connected to the ends of a cell or a battery. It is the continuous path of an electric current through conducting wire connected to the two ends of the cell and other resistances. Now we will come to know, open your book and page number 36. There is a diagram given. So, and what are the components of this electric circuit and what are the symbols? So to study this, पेज नंबर 36 में आपको ये बैटरी हो या की के व्हाट इज कंडक्टिंग वायर, इवन व्हाट इज वोल्ट मीटर, व्हाट इज एमीटर, what are the uses of this ammeter, what are the uses of this voltmeter. So on page number 36, kindly read that page. Now let us discuss about conductors and insulators. What is meant by conductor and what is meant by insulator? This question may be for your Dr. Homi Baba Bal Vaigyanik exam or even at 10th standard NTS exam. हो सकता है. So discuss about this conductor and insulator. So what is meant by conductors? Conductors are the such or the substances which have very low resistances. Conductors have very low resistances or substances through which current flows easily. For example, copper ho, iron, gold, silver, here what all the metals that allows the current to flow through them. So those are conductors. Now what is meant by insulator then? Exactly opposite of that conductor. That means substances which have very high resistance. Conductor में substances which have very low resistances. Insulator में substances which have very high resistance. Or second definition of insulator, substances through which current does not flow easily. Substances through which current does not flow easily. Those are called as insulator. For example, wood, rubber, plastic. So this is about conductor and insulator. Now experimental verification of Ohm's law. You are familiar about the Ohm's law? As long as the physical state of a conductor remains same, the current flowing through the conductor bears a constant ratio with potential difference, that is V equal to IR. This is Ohm's law. So verify this law experimentally in laboratory. So what you have to make over there? You have to make first of all the observation table. That means number of observations you are going to carry. Second, number of cells which are used. Third column, that is about the current flowing through that circuit. As current flowing through that circuit, then automatically the fourth column will be of potential difference produced across the ends of that wire. And taking the values of current and potential difference, that is I and V, you will find out easily the ratio of V by I, which is equal to R. If the value of R comes constant, then the law will be verified. Otherwise, no. Are you getting me? So the value of V by I, that is always constant. That is the R, resistance of that material. So experimentally one can verify Ohm's law. Students, let us discuss about resistance in series. Look at this. This is the resistance R1. This is the resistance R2. This is R3. These are the three resistances which are connected one after another. These are the three resistances R1, R2, R3 are connected one after another. Now, the potential difference which is produced across R1 is V1, across R2 is V2, and across R3 is V3. These are connected between 2 points, and here is the battery. This one is the key K and this one is the ammeter. These are connected in series with each other, where this voltmeter is across this resistance. Let me repeat. Look at this. These are the resistances. This is R1 resistance, this is R2 resistance, this is R3 resistance. These are the three resistances which are connected one after another in such a way that the current flowing through each resistance is same and the potential difference produced across each resistance is different. Such arrangement of resistances is called resistance in series. Let me repeat again. What is the definition of resistance in series? How will define this resistance in series? Very simple, that when the resistances are connected one after another in such a way that current flowing through each resistance is same and potential difference produced across each resistance is different. Such arrangement of resistances is called resistance in series. So these are called as resistors and these are connected one after another. Therefore, R1 resistance, R2 resistor or R3 resistor, and this is the voltmeter which is connected across this R1 or across this R2 or across this R3. So this is one after another. These are arranged or connected one after another. Now if this is the condition, then look at this again. Let R1, R2, R3 be the three resistors which are connected in series. Now let V1 be the potential difference produced across R1, V2 be the potential difference produced across R2, V3 be the potential difference produced across R3. Therefore, the total voltage is V, which is equal to V1 plus V2 plus V3. This is the equation number 1. Mark it as a equation number 1 because the total potential difference between this to this point produced is V, which is equal to V1 plus V2 plus V3, and sum of all the potential difference produced. Now apply Ohm's law over here. According to Ohm's law, what is the Ohm's law? V equal to IR. So this V equal to IR is the Ohm's law. Now find out V1, V2 and V3 from this equation. How will you find out? So V1 equal to IR1, V2 equal to IR2 and V3 equal to IR3. Now put these values in equation number 1. By putting these values in equation number, we will get, for this V, we are going to add IR over here. So IR equal to IR1 plus IR2 plus IR3. Now look at this. I is common over here. Get the common out. IR equal to I into bracket R1 plus R2 plus R3. Now RS equal to, what is S stands for resistances in series. So RS equal to R1 plus R2 plus R3. This is the equation number 2 because here I get cancelled over there from LHS and RHS. Now this is the effective resistances. This is the effective resistance when these three resistances are connected one after another, that is in series. So equation is RS equal to R1 plus R2 plus R3. Now if there are n number of resistances are connected, then what will be the equation? The equation will become RS equal to R1 plus R2 plus R3 plus dot 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 plus Rn, and this is the resistances in series when number of or n resistances are connected in series. Students, let us discuss about resistances in parallel. So what is meant by resistances in parallel? So look at the circuit diagram first of all. This one is the point P and this one is the point Q. These are the three resistances. Here is R1, this one is R2, this one is R3. These are connected between two common points P and Q parallelly. Look at this. Milliammeter, 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 which is connected near this each resistance, and voltmeter is connected across these resistors. Ammeter, battery B and key K are in series with these resistances. Now current flows from this side from plus to minus. This one is minus. Now the total current flowing through the circuit is I equal to I1 plus I2 plus I3. This is the equation number 1. Now as you have studied in resistance in series, there what is the same? The current flowing is same, but here current flowing is not same over each resistance, because millimeter here 1 millimeter is attached. Look at this. This is the second one. This is the third one. That means current is different. So what is different? Current. Write down the equation of current. That total current I equal to I1 plus I2 plus I3. This is equation number 1. Now according to Ohm's law, V equal to IR. This is Ohm's law. That is I equal to V by R. That means simply rearrange the terms. Now find the values of I1, which is equal to V by R1, I2 equal to V by R2, I3 equal to V by R3. Okay. So what are the values? I1 equal to V by R1, I2 equal to V by R2, I3 equal to V by R3. Now substitute these values in equation number 1. So we'll get V upon R equal to V by R1, V by R2 plus V by R3. Now get the V as a common. V by R equal to V into bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now 1 upon Rp, I am putting P over here because resistance in parallel, because here we get cancelled with this V. Now 1 upon Rp equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, where P stands for parallel combination. If n resistors are connected, then what will be the equation? 1 upon Rp equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus plus 1 upon Rn, and this is the effective or total resistances when resistors are connected in parallel combination. So student, domestic electric connections. Domestic electric connections. There are 3 different wires which are used in our home. One is called as a live wire, second one is neutral wire, and third one is earthing or earth wire. Let me repeat. There are 3 different wires which are used at our home. One which is called as a live wire, that brings current and it is red or brown in color, where second one is neutral wire through which current returns. It is blue or black in color. Third one is earth wire, that is called as earthing, and it is yellow or green in color. It is connected to metal plate buried deep underground near the house for safety purpose. In India, the potential difference between live and neutral wire is about 220 volt. Now, what is about fuse? And what is the use of this fuse? Fuse, it protects the domestic appliances when current in circuit increases excessively. The fuse gets heated up and melts, and it breaks the circuit and stops the current to flow. Therefore, whatever the electrical appliances are at our home, they become safe. So fuse protects all these electric appliances. Now what are the precautions to be taken while handling the electrical appliances? So very simple, that electric sockets or switches must be fitted at height away from the children. Switch off the current before cleaning the electrical appliances. Hands should be dry while handling electrical appliances. Use rubber gloves or footwear while handling electrical appliances. Do not touch a person who gets shocked. So go immediately and switch off the main switch. If you don't know where is the main switch, then push that person with wooden pole. So these are the safety precautions one should follow while handling electrical appliances.